All right. So I'm Nate Adams, sometimes known as Nate the House Whisperer. And I've been wanting to do just occasional, like non-regular conversations with friends of mine that either I find or I think people will find really interesting or that are timely. And so this episode is a timely one, as well as hopefully interesting, with my good friend and HVAC educator, Ty Branaman. So we met a year ago at Brian Orr's conference down in Orlando, Florida. It's kind of known as the symposium at this point, the HVAC symposium. And Ty and I just kind of hit it off with each other. And it's kind of funny because tonight is the first time we've heard each other's voices in a year, but we've gone back and forth on Facebook Messenger for the months, especially when we were out traveling out west, and so were you. So we were within 20 miles of each other twice on that trip, and it was just hilarious. We never quite connected, but here we are tonight. And you moved back home to Texas after a little bit of being a nomad, and so last week was mildly eventful, shall we say?
It was.
So Ty, you want to give a little bit of your background so everybody can hear about that?
So I started doing air conditioning, sheet metal work in 1995. Been in metal with my dad, building ductwork. And I was always intrigued about how does this work? How does that work? And so I just kept learning more and more. And now I'm a certified master HVAC educator, and I get to teach others. And the curiosity still keeps what's my drive. How does this work? How does that work? And there's so much more. You can never learn it all. And I just surround myself by intelligent, smart people and people like you and Brian that just full of energy and information. And I just want to learn as much as I can all the time. And I'm always challenging myself. And then I found ways to break it down for other people to understand and appreciate. And I have a ton of passion for what I do. And sometimes that irritates people, and sometimes people love it. But it's always meant positive. It just doesn't always hit that way. So I think when people hear me in person, they get to appreciate that. Sometimes in the text, it gets kind of harsh, but I love this stuff. I truly love HVAC, as my email says.
I know you do. Do you remember the scene from Juno? It's kind of a funny movie. It's this teenage girl who gets pregnant by accident, like from a friend that was just like, we'll just try this one time, and she gets pregnant. But when she's interviewing someone to adopt the kid, the prospective adoptive parents are sitting on the couch with her and her dad, and like, so is there anything in your life that you just feel like you were just meant to do? And her dad's like, yeah, heating and cooling. And I think of you when I think of that scene. It's just like, this is what you Jones on. And I'm so thankful to know you because you get to teach me a lot of things. Because I'm not a tech, I have exactly zero formal HVAC training, which is hilarious in a lot of ways, but I have no training whatsoever. It's just going out there and trying to figure stuff out. And not a bad way to go sometimes.
That's what makes life fun, figuring things out. I mean, that's what we're always doing, is figuring stuff out in one way or another. And it just keeps it interesting, keeps you engaged.
Yeah. So, well, speaking of that, you mentioned that you used to hate heat pumps.
I used to.
Tell me about that.
So, gosh, about 20 years or so ago, I was anti-heat pump, pro gas, simple systems, and I hated working in the cold. And I was a non-believer in heat pumps, and as well as most people around me were. Yeah. And I had one man, Brian Orr, come to me and he said, "Ty, what do you hate about heat pumps so much?" And I told him the few things I knew, and he started asking me a bunch of questions, and I didn't know the answer. And he said, "Well, how about you go find out the answers, and if you want to hate something, that's fine, but learn everything you can about it first and have a good opinion on why you don't like something." And so I was hard-headed and determined, and I'm like, well, yeah, I'm going to show you how horrible these are, and I'm going to find all that information. And then the more that I studied it, the more that I learned about it, the more interesting it was. And I'm like, well, that's quite fascinating, the history and where it started and all these people. And I was just kept learning more and more and more about it and how they worked all across the country. And I just was fascinated by it. And then once I understood how they worked, it was so easy to work on them. And then from then on, I just fell in love with them. Hey, we're moving heat. It's what we do. We're heat transfer specialists, and heat pumps a beautiful way of doing that. And so I've just loved heat pumps ever since then.
So do you also find it elegant that they use so much less energy, yet they deliver the same amount of heat?
Yeah, I think it's just amazing how, a 4-to-1 ratio in some circumstances over, electric heat's 100% efficient, and this is 400% efficient. That's just awesome. And now we can go down to what, -40 without auxiliary heat and still heat. I mean, that's amazing. Yeah, there's some lost capacity, but the fact that we can do that, that's awesome.
Yeah, I love them too. I even though I have at least a decent understanding of the refrigeration cycle, I tell people it's the closest thing to magic that I know of. Because it's just like a plane. Like every time a plane takes off, I'm like, I understand the physics of how this is happening, but I'm still just amazed that we're up in the air.
What's funny, I traveled to Cambodia and I did some works with orphanages there, and they asked what I did. And I said, well, I teach air conditioning, and they had no concept of it. And so the closest thing we could do was I was a magician that changed the weather. And then they're like, make me change the weather for us. I'm like, I need my equipment. I need my tools. But it's just, there was no, connection to it. And sometimes that's how it is with heat pumps. Yeah, we're pulling heat from the air outside and bringing it inside, and people's eyes just get this big. And I realize it's going to take some time to fully explain and for you to appreciate this, but it's really great. I love if somebody has the time to sit down and talk with heat pumps, and I can go over everything about how they work. They're really ultimately simple, and our technology now has made them very efficient and last a long time. I remember the old time clocks from the 70s that were just a nightmare to work on, and the clocks would go bad. And now we have this one little control board that does everything for us, and people hate the control board. I'm like, no, I love the control board. I remember sitting there freezing to death trying to diagnose these things. Is it the clock? Is it the relay? And going through all these steps. And now we got this one board. It does 3 things. It does these 3 things and undoes those 3 things. It's so nice.
It's so fun that it happens. So along that same line, you had 2 very direct heat pump experiences last week. So why don't you tell me about what happened at your neighbor's house?
So we had a guy talking about heat pumps and how they didn't work below 30 and 35 and 40 degrees. And so it was 14 degrees in Texas, which is very rare. And I went over to my neighbor's unit, and it was heavily snowing, and I had a full ski suit on. I looked like the kid from the Christmas story. I could barely walk with all my gear on.
It was his only defense.
So we go out there, and me and my wife, we make a video on heat pumps, and it's 14 degrees and it's snowing like crazy. There's ice everywhere, and here's our heat pump running beautifully with just heat pump, no auxiliary heat, which was probably oversized for the system at that design. It should have been struggling, but it was running just absolutely beautiful, and it was running great. I mean, it's just running great. So I started talking to some of my friends that still do HVAC in the field, and their heat pumps, as long as they were working properly, didn't have any issues. Now, it starts icing up, not frost, but ice, then there's some issue that needs to be addressed. But they were just running really, really great. And I tried putting some pictures up and talking to people about this is a heat pump in Texas, and they do work. And so many people are stuck in their ways. They just want to find issues to attack. But I'm like, hey, if you're open-minded to this, let's talk about it, let's communicate to it. But if you just want to argue that side of it, then it's probably wasting both of our time. But I've got to use that story and talk to people, and it worked wonderful. Even our own heat pump in our little house we have, it's just a high wall ductless mini split unit, and it was keeping out really well. Extremely cool. At nights we got down to 5 degrees, and it struggled a little bit. We lost some temperature because there's no auxiliary heat on our system, but it did pretty good. We had I was real impressed with it, and I was just reaffirmed my love for heat pumps.
What size were each heat pump, and what type?
So the my neighbor's system, theirs was I think a pretty good sized house. That was I think it was a 4-ton heat pump system that they had, and it was your standard unitary system. Theirs was a 1995 model system.
So 13 SEER or 10 SEER, something like that?
I think it was right at 13 SEER. It was a
Which was
high
good
end
for the
unit for
time.
today. Yeah, the day it was a good system, good duct system, good. Everything was just a nice install, just a pane unit, so plain, nothing fancy system, and it was running great. And then ours was just it's a cheap off-brand ductless system because I don't stay in this house very often. This bunkhouse, barn, cabin, whatever you want to call it. So it's just a temporary place that we stay from time to time. And so we slap something in there, and it's all electric. And it, as old as it is, it hangs in there pretty good. And I keep thinking, yeah, I'd really like to upgrade that. And then I think, no, I really want to go travel. That's my ultimate goal. But it did really well considering that we've added on to it since then, and it held up. It held up. I was quite impressed. And this thing needs to be sealed. It needs some foam. It needs some plastic. It needs something because when the wind blows just right, you can feel it blow through there. And somebody asked me what was my blower door in that, and I said, well, I'm pretty sure it'd be the same as an open window. But but that heat pump did really good. We got down, I think, 60 degrees one night when, as long as we had solid electricity. It got, it's a little cool, but we put an extra blanket on, no auxiliary heat other than a little heater in the bathroom, and we stayed comfortable. My neighbor's house, they had their thermostat set at 75, and it's a little bit high, but you were talking about Texas, and they didn't run auxiliary heat until they went to defrost. They were comfortable.
So the one in the bunkhouse, was that a 1-ton unit, something like that?
It's very small. I think it was a 1-ton or a 3/4 ton. It was the smallest thing we could get at the time, the absolute smallest one, and it's a no name brand, just basic little unit that I really thought would have given out by now, and it's just pumping away.
How old is it?
Gosh, it's at least 10 years old. I'm losing my concept of time now, but it's at least 10 years old. It may be 15 years old. I can't remember.
Wow.
It's been there a while.
Okay. So this is not brand new technology. I mean, it's an inverter, I would expect, but it's
no, it's not even an inverter. It's just
really.
Yeah, it's I think it's pre-inverter. It's basic. It is just a simple little. I mean, it's not even off the ground. If the snow was to build up much more around it, it would have. I was surprised we didn't even have that issue because I thought, oh my gosh, it's going to freeze up with the snow builds up around it. But wasn't even an issue for it. I was impressed.
Well, so you mentioned defrost. Can you go into teacher mode for a moment and tell us what a defrost cycle is and what the intervals are and how that was a problem in some cases and not in others?
Absolutely. So a heat pump will frost up. I mean, the evaporator has to be at a lower temperature than the outdoor air to absorb heat. So as the outdoor temperature drops, the heat pump evaporator temperature has to drop even lower. So it will frost up, and it goes into a defrost mode to melt that ice off. And when it borrows some heat from inside, melts the ice, and then puts that heat back inside. So it's a pretty cool process. I won't get into all the details of everything it does, but it needs to go into defrost ever so often. Now, you have to be careful how you set it up, because if you do it too long, then it will build up so much frost it turns to ice, and that ice is going to be an issue. It won't have time to melt it before the next defrost cycle. So it's going to detect ice or frost over 2 points, time and temperature. And this is your basic, most common defrost. We have new ones now that are on demand that are awesome, and we'll get into that later. But your basic defrost over time and temperature. So you have a thermostat in there. It's a freeze stat. And when that gets below usually about 32 degrees, and it has 30 minutes, 60 minutes, or 90 minutes, then it will initiate defrost. So as long as that defrost sensor is above a temperature, even if you set it in a low interval, it won't freeze. But a lot of people that don't understand heat pumps think defrost is wasting energy. So they set it for the maximum defrost time, which is great for a place like Arizona, Nevada, that has no moisture in the air. But then in Texas, you have a few different climates. You have some that are drier than others and some that are wet. But pretty much most of Texas should have no more than an hour defrost, or I recommend 30 minutes. If you don't know, set it for the shortest time. So what happened was in Kerrville, it's a pretty high moisture content area near rivers, a lot of trees, a lot of moisture in the air. They were setting their defrost timers for a very high amount of defrost, the maximum on it, which is usually 90 every 90 minutes. So the units had built up so much frost at that point that even when they went to defrost, they couldn't melt the ice off. So they just kept building up more and more ice on the system. And everybody's first thought was, oh, it's just a heat pump. They just freeze up. That's what they do. If it's below 35, 40 degrees, turn it to emergency heat. And that's horrible, because now you're burning tons of kilowatts. You're putting a heavy load in the grid, and you're costing the customer a whole lot of unnecessary money. So if the heat pump's freezing up, there's something wrong. And the first thing I look for is to make sure that the defrost interval is set correctly. And if it's set correctly, or even if it's set incorrectly, but on the lower side, it may go to defrost a little bit more than it needs. But I'd rather that than have a damaged heat pump or having to put it to emergency heat when you need it the most. So if you set them up properly, I mean, they really work great. Plenty of drainage around it, low intervals, and it's good. So the one company we'd talked to, the guy had set them up for a high intervals, and he honestly thought that's what they were supposed to be, and he truly believed that it was just due to moisture in the air. He honestly believed it. Now, luckily, when I got to finally talk to the guy, he was open-minded about it, and we got to actually talk about defrost, and he was open to saying, "Oh, well, yeah, we set them for that. That's what we thought we were supposed to do." And so I'm going to actually go do a class with him and help him out.
I remember you mentioning that, and that's a testament to your personality, because you posted that one post, and I actually retweeted it on Twitter, and then we both had put it on Facebook, and we're kind of going after the guy, and I love that your open-mindedness picked up the phone and called him and asked questions and helped him understand what was going on. And so he was open to the ideas, and holy cow, you're going to go teach him something now. So, I mean, that to me, I'm like, that's Ty right there. If you want to know who Ty Branaman is, he is such a kind and gentle teacher that he can get people to move you wouldn't expect to move. So I love that. So I'm looking forward, because we've been chatting, and I look forward to having you involved more in HVAC 2.0 and doing a bunch of teaching, because you're gifted, and you're empathetic, and you're good at connecting with people.
Oh, I appreciate it. I love this stuff, and I just want to help people. That's why I got into teaching. Teaching is the lowest paying job I've had, but it's I get to really help people, help somebody see it a different way, because everybody learns differently. And I just got to think of, how does that person perceive it? What's their driving force? And so for a business, their driving force is, hey, I got all these customers and I have to deal with this issue right now. So once I understood what his main goal was, then I could work around that. And that's with anybody. People get calls and emails all the time, people having questions, and I don't always know the answer, but I am blessed to have so many people that I can call and ask. And I've asked you many times, hey Nate, what do you think about this? And you'll tell me, hey, I think that's a bad idea, but here's the information for it. And I just love our conversations, because it just gets me thinking, and then I'm all excited again. So when I finally got to talk to the owner, and he was willing to talk with me, I was so excited, just because we could actually talk it out, regardless of the result. The fact that somebody's open-minded, and if we all stay open-minded and willing to listen to the other person, and not fully try to change somebody's mind, but just, hey, here's the information. And I tell people, hey, it's okay to argue with me. Bring me information, though. Don't just say you heard or somebody said. Bring me something I can read, and we can go from there. And I think we would all benefit from that.
That's no fun on social media. Why can't we just take shots at each other and call each other bad names? So, which I can be guilty of sometimes. So I will admit that. So your heat pump was doing okay until the power was out for a good while, you said.
So once we had the first blackout and then the rolling blackouts, that's when things got really challenging. So once we had that long blackout, then the temperature of the house dropped pretty fast, because it wasn't sealed. Had our house been sealed, we would have been way better off. But the temperature dropped, all the pipes froze, and the power would come on for a little bit, and then it'd go right back off. So our heat pump, when it kicked on, it couldn't keep up. Even with our little electric backup heater, it was a lost cause. So we ended up abandoning ship, and we went over to my parents' house and stayed with them. They had a wood burning stove, which helped out during the power outages, but I still went and checked on our neighbors. At that point, what's interesting was the heat pumps were actually, that intervals when they were going off with the rolling blackouts was resetting the defrost. So at that point, even if it was set for 30 minutes, you only had electricity for 20 minutes. So now the heat pumps are actually building up frost and building up ice, because every time the rolling blackout would hit, it would wipe the timer on the board, and the board would start over like it was first powered up. So their unit was starting to freeze up, and I defrosted it once thinking maybe it's an off thing. I checked everything out and it was just happening. I was thinking, what's going on? So I started contacting some of my friends in the field, and they were having the same issue. But they only had the issue where they had the rolling blackouts. Places that still had power, their heat pumps were running great. So it introduced me to a new problem of we're having the rolling blackouts. It's making the heat pumps ice up, as well as emergency heat was running, or auxiliary heat was running. So they were trying to run their heat pumps and those electric heat elements, trying to get the house heated up really fast. So now it's putting even more strain on the grid. And so I just started seeing this and started thinking about all the problems. I even contacted the local news about it. I didn't get a response back, but I was thinking, wow, this is valuable information. And I posted on HVAC 2.0 because I'm a nerd in this stuff. I just thought, I've never thought about this scenario. I've never thought about having this kind of a problem and building up. So I was just fascinated by it, and obsessed with it, really, the fact of all these moving parts with it. And I was just thought it was so interesting that nobody ever thought about the defrost board resetting during rolling blackouts. I don't think there's ever been a condition that we've seen before. So that was actually causing a problem with heat pumps. And it's probably one of the few times that I would recommend putting it to emergency heat, hopefully one that never occurs again. But it was something I'd never seen before, which is why I'm also a fan of on-demand defrost. Some of the new systems have a defrost with a measuring pressure drop across the coil. So instead of waiting for time or temperature, it says, hey, we're having a pressure drop because of ice. We're not moving as much air. Then we go into defrost, which I think is a fantastic idea. And that's just, we grow with technology, and I'm looking forward to more and more heat pumps having those, or even having those boards that we could retrofit to older systems, because on the units in Texas, even if we had the rolling blackouts and it was sensing ice and it went into defrost automatically, we would solve that issue.
So is that an easy thing to retrofit if there was a product for it?
It would be. It would be, but you got to look at demand. You got so many people, especially in Texas, that are, they're pro gas heat, trying to get that to change over and get enough market for people to buy it so that a manufacturer would want to produce it. And then this is what's a once in a 30-year thing that's happening. I don't know that the cost would be there. There's probably other things that manufacturers are going to want to do versus this. And too many of the AC companies that say just turn it to emergency heat, they wouldn't be looking for that root cause, which hopefully I can, do some more training for some more companies around to let them know about, those intervals. But I would love it. I would love it if they had a retrofit kit for that, because that'd be really great.
I can send this to a couple manufacturers, and maybe something happens, maybe not, but it's worth a shot. So the units that have on demand, do they happen to generally be the higher end variable speed heat pumps?
Yes. Yeah. It's usually above 16s here.
Okay. Is there a certain kind that I tend to prefer?
I used to love brands, and
I'm not even talking older, brands. I'm talking general varieties. I don't like single and two stage generally.
I love the inverter series. It's when we have our cars, we don't have just an on and off switch. We have a full gas pedal we can control our load for. So, having a unit that can adjust itself to its load it just makes sense. We have the technology for it, and I think that's the way to go.
And in that case, you get the on-demand defrost board, so that if there is a big power outage, it's not a huge deal. And also, do they tend to soft start so they don't pull too hard when they turn on?
Absolutely. If you had a battery system, that would be ideal, what you'd want, because you're having that soft start. You're not having that big draw, that inrush current on a regular unitary system. I mean, that's a ton of load on those. If you put a meter on that system, when it fires up, it just spikes like crazy.
Yeah.
So that soft start, I mean, it really makes a difference. And it's better than electrical connections. Electrical connections are our number one issue for electrical failures. And if you have that nice soft start, you don't have that inrush current. You don't have all those connections overheating. It's just a win-win situation all the way around.
It's so funny. I put out the Electrify Everything course 2 weeks ago, and then this whole thing happens. But I keep talking through the whole thing. Like, you're going to get tired of hearing how often variable speed inverter-based heat pumps are the answer, because they are like everything.
Yeah.
Ideally there'd be a little smaller cost difference between them and the the single and two stage stuff, but there's such nice benefits that come from it that I view it as a kind of personal challenge to help show clients what the value is and see if we can bump them, the several $1,000s extra that the equipment is.
Absolutely. I tell my students, I said, think about if you could drive your car from home to school without ever stopping. You could just speed up and slow down as you need, but you never stopped. Would you get better mileage? Would your car have less wear and tear? And they're like, well, yeah, obviously. We have air conditioners that do that now.
Boom. See, and there you are. So if you're a teacher, analogies are so key. I've been called the analogy king by a couple of people because it's how you help people make connections. So it's kind of like this, only a little bit different. And over here, that's such a key thing. So let's see, what was the other thing? Generators. So you've had some experience with those in the last week. So tell me what's happened.
Yeah, so I'm a big fan of energy and how it's being generated and all the different processes. And interesting that Texas has so many different ways of generating electricity. They have nuclear plants, they have coal plants, they have gas plants, they have a little hydro, they have the windmills and a little bit of solar around, but they have a huge variety of it. So when I first heard about these windmills freezing up, I was shocked because I didn't even know that was an issue. So I immediately had to go into my research mode, and I called my friend that used to work on the windmills, and I'm asking him about it. And then I'm going and doing research, and I found out they're in Antarctica and Sweden and all over these places that are cold, and realized, oh, they can work. They just need this kit for it. And then I found out it was a political agenda. They were blaming the windmills, and I got to read the reports from the ERCOT that was saying that was a small percentage of it. And then the winter, they don't produce that much electricity because there's low wind anyways. Mm-hmm. So then I found the cause of it being natural gas, and not just natural gas. I'm not hammering natural gas, the fact that they were diverting natural gas away from generators, and then the wellheads were freezing. And a lot of people don't realize that these natural gas plants are run on electricity now. They found out it was more efficient to run these big giant compressors on electric motors than it was running them on gas motors. So the electricity, the gas generation plants and the wellheads and all this stuff is running on electricity. So when the rolling blackouts happened, it just magnified that even more. One of my friends worked at a gas plant down in Fort Stockton, and they had a generator engine that they said, I don't know for sure, but they said it was the same one used in a nuclear submarine electric motor. So I was like, well, that's really cool. So you can imagine these rolling blackouts just magnified that problem, even greater. So everybody was talking about generators and needing to have a generator. And my mom and dad have a generator, and it's been sitting for so long. I talked to my dad about it, and he's like, geez, that thing was always hard to start to begin with. And by the time that we get it all cleaned out and get it running, the electricity is going to be back on. So many people, though, they have these generators and they'll service and maintain them at first. But then after that, the cost of maintaining them, service them, keeping the fuel changed out, the fuel treated, when they need them, they're not there. They're not ready to go. And there were ads in Texas looking for generator mechanics, people to go out and fix these, because so many people that had generators, they wouldn't work at all. Yeah. So it's nice. It's a luxury to have a generator, but to have one that works when you need it, to have the fuel issue solved, to have enough fuel on hand. Fuel goes bad when you store it. Storing fuel's a danger issue. On top of that, there's so many moving parts that ideally, yeah, I'd love to be able to just flip a generator on and have power. But the reality of the cost over benefit, and you figure this happens every 30 years, if I bought a generator now, would it still be a good enough shape to use it? And would I have it maintained all these years? I could probably invest that into something else like solar or batteries or, several other causes.
What about natural gas generators? We were talking about that earlier.
Yeah, so I think now they're making generators that run on natural gas and propane that solves the fuel issue, a lot of that fuel issue. But in Texas, you figure we had a gas delivery issue to begin with. You're looking at, are you going to have natural gas when you need it? and then you have propane stored on site. But propane, when you're pulling it out of the tank, the temperature of that tank drops because it's HVAC, so it's evaporation, boiling. The temperature drops. I'll save that for another time. But it actually becomes a refrigerant. So the temperature of the tank and the propane is going to drop, and the temperature outside is already low. You can have pressure issues with your propane tank. So running a generator on it could potentially be that issue if you don't have it heated and warmed. So with everything, there's a positive and a negative. You figure that the cost over benefit, everybody has to look at it for themselves: space, storage, and it's a motor, an engine. If you have a 10-year-old vehicle that's been put in a barn and you pull it out, you're going to have to replace things because rubber, cooling generators,
Things go bad.
Things go bad. Moving parts.
Yep. Yeah. The worst thing you can do to a machine is let it sit in general. Machines like to work.
That's right.
This is an interesting intersection with the electrification movement as well. So the natural gas generators, I see twin problems of, like you just mentioned, we already had supply constraints. And I don't know that that's going to get fixed for the next time that something like this happens. And then the secondary thing is it would harden someone's will to stay on the natural gas grid. Like it's going to continue the grid longer because of that. So in my mind, ideally, we would avoid adding a whole bunch more natural gas generators. That said, I was just on a distributed energy resources in a room on Clubhouse, and they were saying every Generac salesman is going to have a new truck in a few months because there's going to be a lot going in. And I'm like, well, that's kind of, just hardening our reliance on this stuff. And
right.
I'm like, well, that's kind of how it goes. So that's one side. The other side that I was kind of curious about, I've seen this in two utilities. So Green Mountain Power in Vermont, and I believe it's Holy Cross Energy. They're way up in the 14ers in Colorado. And both of them have made it so that for about $50 a month, their clients can get 2 power walls at their house. And basically they get access all the time to half the battery, so that when the grid needs help one time or another, they can do it. But if the grid goes out, that client has backup power. And I just find that kind of an elegant solution to this sort of thing. So, I mean, for a long outage like just happened, you're still going to probably need a generator. My leaning would actually be a gas generator, but to purposely drain the thing so that you put fresh gas in it. But that's just my leaning. And that may not be perfect anyway. And would I be good enough to remember to drain the gas? Probably not. Let's be frank. I suck at maintenance. So, and most people do.
Most people do.
I mean, when we design for the systems in HVAC 2.0, our number one assumption is that it won't get maintained, because that's the only safe assumption to make. Let's put a really good filter in there so that if it doesn't get changed for a year, it probably won't break the system.
Exactly.
Will it work? I don't know. But anyway, I would love to see more utilities do that sort of thing. But in my understanding, most of the utility rules don't allow them to own an asset that's at a client house, so basically behind the meter. So there's some issues there. But I do think that would help with a lot of this stuff, particularly when everybody's equipment slams back on at the same time when the grid's turning on. It could help be gentle on that. So I don't know. Anyway, those are a couple things going through my mind as I'm watching all of this. And you mentioned another key point, which is how you could feel the wind blowing through the bunkhouse. So do you think this might move you towards insulating and air sealing a little better, or do you think it's totally fine too if you're like, probably not?
It's the first thing in my mind every time I get back to the bunkhouse, but my main priority is travel and nomad life. meeting as many people as possible, seeing as many things, learning as much as I can. So every time I come back to the bunkhouse, I think, oh, I want to do all these things. But then I think, no, my main goal, I got to keep that main drive, my main issue, what I want far. And I'm a little bit backwards from most people. Most people, their house is their castle. That's where they're going to be forever. And at that point, if I was going to be there for more than I am, a few months at a time, I would be doing it immediately. And I will probably still do it because there's a lot of simple things I can do to solve those issues that I will be doing. But my main thing is I love to travel. I would love to chase the sun or have eternal summer. but insulating the house, my parents' house, when we built it, it was extremely well insulated. They built their house inside of a shop, and the shop was also insulated. So it's very well sealed. And then there's a second shell that they heat with a wood burning stove. So having that wood burning stove, having that 2 different layers of it, they didn't suffer. Their gas furnace was a bit oversized, and my dad gives me a hard time because I was trying to tell him, hey, it's oversized. And so he was telling me this last time, it's oversized, huh? Feeding you pretty good now. But you wouldn't try to tell him you don't size your furnace for a once in a 30-year situation. But it's my dad, and I just realized, yes, Father.
Yeah. Yes, boss.
Oh, you're cutting out again, Nate.
What's that?
There you are. You cut out for a little bit. It's hard to hear you.
Was there anything else you want to talk
about? One other thing, I know that a lot of people were really upset and scared about it. I know my mom was very nervous about this, and she was just really having a hard time dealing with it. And we live, in the country. We have well water. We have, it's a full Texas house. We got guns. We got game deer. We got food storage. We got everything we need. There's nothing to worry about. We have a welder that we can power the furnace with. We have a generator that we could work with eventually and get it running. We got tractors. We got, everything we need to survive. We could live off grid for a while. But it just got me thinking about so many people out there that didn't have any of these other things, any of this other survival gear, or even the knowledge to know how, and they're at the mercy of all of this. And for those people, I was thinking they really, getting the grid situation fixed, but also thinking about, battery issues, house being sealed well. If you had a house sealed well, even if you had to get some propane tanks to heat up, which is a issue with carbon monoxide, but at least you could have some kind of heat in there. If the house was sealed well, you're not losing that heat out. You could benefit greatly from it. There's a lot of things to do. But how easily we depend on that electricity, how easily we depend on water. So when you lose water and you lose electricity, you're losing 2 big issues. And by the time you finally get to the store and the store's out of food, you think, wow, how we get so relaxed on these things. And so I was fine with it, but I got to really appreciate how many other people were affected by it mentally. And I had friends from all over the country, actually all over the world, calling me and sending me messages. Do we need anything? Is there anything they can get for us? And I just felt, really blessed having all those connections. But, a lot of people out there were really, really freaked out and really scared about it. And I just really feel bad for those people. I know I'm enjoying looking at it and the science behind it and thinking my way through it, and I was a bit obsessed with it because there wasn't really anything else to do. But I learned a lot through this, and I really hope we don't have to go through something like this again, whether it's people taking initiatives on themselves or government sides or whatever it is, because it was really bad for a lot of people and still really is bad for people. The issue with water, not having the drinking water out. Yeah, coal froze in the hoppers, and I didn't know that was even a thing that could happen. I didn't know that a nuclear power plant would shut down when it got too cold. So that weatherization is, it's huge. I didn't know that some of the machines that were working, the generators themselves, the instrumentation froze, and that shut some of the equipment down. There was so many different variables that happened with the shutdown. So it wasn't just one cause. It wasn't just the gas. It wasn't just the generators. It wasn't just, there were so many multi-levels, and really ERCOT has a lot to answer for. The reliability of Texas, the Council of Reliability not being reliable. I think that's their whole mission for existence. So it'll be interesting to see what happens. I know there's a lot of trials and meetings coming up from that. And I think we'll be studying this for a long time. I think this is going to be a good study point, and we're going to see more and more information come from this as we go. Every day I'm seeing more information, more things I've learned from it. So this will be a big study point and I think the whole nation can learn from what happened with this, and hopefully, we can solve a lot of issues before they become problems, and be prepared, prepare everybody for this. Yes, if anybody has anything they want to, ask about, I don't know everything. There's so much stuff I still want to know, but everything I do know, I make videos. I got my little YouTube channel. It's not much, but just trying to help people out with this information, like heat pumps. I'm doing a whole series on heat pumps right now. I love how things work. I love taking things apart. And if you understand something, you want to know it more, just let me know. I'll help any way I can, and look forward to doing some HVAC 2.0 stuff. Put it out there.